I'm going to record this also, which, so afterwards we'll post this on YouTube. That doesn't mean you should get up and leave now because it's going to be on YouTube later. It means that you should totally hang out here. Yeah, I have my phone on vibrate tonight. It's weird for me to do that. I could get that out of the way. You don't care to look at that, do you? Come on now. I wish that it would properly mirror. Let's see. There we go.
There you go.
There we go. That's better, right? Except it's not really.
It's kind of awesome.
Oh, that's not bad, right? There we go.
Business.
All right. Looks like shit over here, but that's fine. It doesn't matter. Okay, so hi. As Jessica mentioned, I'm Nathan. I am the VP of Community Development at Chef. I also co-host the Food Fight Show. If you don't subscribe to that podcast, I highly recommend that you do because it's an awesome podcast. It's all about chef and DevOps, and it comes out very infrequently. So I'm sorry if you have a long commute. It's not going to solve your problem. But if you do have a long commute, I've made a commitment. I'm making a commitment to you tonight that 2017 will be a good year to reboot that podcast. So there are some other lies about me there, like I'm an occasional farmer who loves eggs, but I am totally into the hug offs, so you can check out all of those URLs if you'd like to find out more about them. So I want to talk tonight about InSpec and compliance. So before I do that, I want to understand a little bit more about you first. So how many of you are using Chef today on your day job? Okay. And have ever? Okay. Cool. How about InSpec? Anyone using InSpec?
I have a pipeline.
You have a pipeline. Okay. Cool. Yeah.
I have one.
You're wearing a suit, you don't count. I mean, you're the chef, you don't count. Sweet.
You have a suit and work at Chef.
Yeah, you have a suit and work at Chef. Something is wrong here.
Right.
Anthony, I hope you can hear us okay. And if you're probably muted, and I'm definitely muted, so if you tell me that you hear us, I don't hear you. But you can tweet it at Jessica or something. That would be awesome. Anyhow, how many of you develop applications? Anyone write applications? You manage infrastructure? What do you do? You're a sysadmin? All right. Yeah. And you do everything? That's cool. You do all the things. John, what are you doing these days? What do you call yourself these days?
Ops manager.
An ops manager? Not a DevOps manager? Okay, good. And what about you? Engineering manager, awesome. So I myself have done everything over the years, including application development, a lot of operations management. Now I do community development, which means I get paid to get on an airplane, fly to a meetup, and drink beer, which is kind of awesome. It's a nice job if you can get it, I'm telling you. But when I was developing applications, you know, the flow kind of looked like this. I start in dev, that's my local workstation, and then it moves to the QA, staging, off into production, you know, pretty simple stuff. And of course, I'm using Chef to automate the build out of all that infrastructure, which makes it super awesome. So what I want to do tonight, I have some slides, but the slides are interesting. I don't know. You can tell me later. But I also have some live coding that I want to do because why get on an airplane, drink beer if you're not going to also live code in front of an audience? So we're going to do some of that. So let me start by sort of introducing you to this application that I have set up here. Man, oof, not like that. That's better, almost. Yep. There we go. Okay, this application that I have is, well, I have to tell you, it's awesome. Yep. Or it was awesome. Sure, it's awesome.
There we go.
There it is. Look at that awesome website. It's pretty amazing, isn't it? What do you think? Yeah, it's beautiful. I built this website, and you know, I'm a good developer, so I manage this website in Git because version control matters. And in fact, if you want to follow along, I actually have it here in a GitHub repository, or repository on GitHub. So I came into work today, and what I want to do is kind of share my workflow with you. So I'm a developer. I might go to a waffle board or a Jira board. Tonight, I'm just going to go to my GitHub issues, and I see that I have a couple of issues that need fixing. So I'm going to go ahead and fix those. But before I get into fixing them, let's just take a look at the code that's here. Also, can you answer that question for me?
Yes.
Yes. Now, can you tell me the answer to that question?
Yes.
Okay. Because you see what I did there? I asked if you could answer the question for me, and you said yes, which told me that you could answer the question. Didn't. Well, anyhow, I'm a father of 3 small children, so the dad jokes are. Yeah, I'm not really sure if you've answered the question yet. So let me just open this up in my editor here so we can take a look at how this thing gets built. Some of you said you've never written a recipe before, right? A chef recipe? Or at least don't write chef recipes currently today. That's big enough for you to see? Yeah? Yeah. Okay, so here's how Chef works. This is like the 30-second overview of Chef. You write down a policy of what you want the infrastructure that you're managing to look like, and then Chef makes that infrastructure look like that. That's basically it. The policy that you write down is a recipe that's stored inside of a cookbook. Yeah, so here's what a recipe looks like. This is a really boring recipe, but I bet you can, together we can figure out what it's doing. So the first thing that it's doing is it's including this other recipe called apt. Then it's including a bunch of other recipes that are all in this same cookbook. So this is the Simple Web cookbook. There are a bunch of recipes here, including a firewall recipe, the Apache recipe, a website recipe, and a hardening recipe. The one that's interesting, most interesting for our purposes right now is this website recipe. But I'll just talk through what each of these do. The apt default recipe is a stupid recipe that just updates the apt caches on that machine. The firewall opens up some ports. The Apache recipe installs Apache. The website is the thing that runs the website. And then there's a hardening recipe that, well, it does some hardening of the OS. What it does is inconsequential, I'm sure. So what happens in this website recipe? We create a directory called whatever the attribute value of Simple Web document root is. And let me just show you how that works. So in this Simple Web cookbook, there's an attributes file, and here we have a default. And so Simple Web document root is set to var www.html. So the way that this recipe works, sorry, the website recipe, we use a thing that we call a resource, a directory resource. We give it a name, and that's the full path of the directory that we want, var.www.html. And then we can set up some attributes or some properties of this resource between the do and the end. We say recursive equals true, or recursive is set to true. And so what this is going to do, Chef is going to come along, look at this node, and say, is there a directory that exists at /var/www/html? If there is, what is Chef going to do? Nothing. It will do nothing. We'll say, all right, that guy is following, that resource is following its policy. If not, it will create that directory for you. And then it'll move on to the next resource, which is some template, Simple Web document root. So back at var www, we want to write out an index.html that's stored over here in a template directory. So under this templates directory here, and so forth. So the basic thing of this recipe, we create a document root. We write our index page to the document root. We set up a directory for our CSS. We write out our style.css, which again comes from another template. And then we add some images, and we're done. Like, that's what this recipe does. It's not super exciting. It is super awesome, as you saw on the website. When we looked at the website, it told us it was awesome. So we know that it's awesome. But let's go back. Sorry, before I go back, any questions on how this works so far? Pretty straightforward. All right, awesome. So let's go back and look at our issues. The first issue that we have here is that we're using the wrong blue on the home page. That's bad. But luckily, it tells us right here which blue we should use. So if we actually go and, I don't know, where might that blue be found? Where might it be specified? In the CSS, right. So there's this style.css, and if we look at this source, there's a css.rb here. That is a template. So if I look at that style css.erb, we can browse through this and see there's a bunch of like CSS looking things here. But somewhere in here, I believe, there's this thing here that says the node, that the background color should come out of our attributes, website color. So if I go up here to my attributes and look at this, I'll see there's the default website color is set to blue right now. We're going to change that to this. Now, another thing that you may have noticed is that this cookbook was written by an Englishman. Yeah, John noticed it. John definitely noticed it. So in the lovely world of open source, I've not written any of this code myself. I've simply stolen it from someone else. When he speaks, he sounds much more intelligent than I do, though, because, well, English accent. So I'm just going to change that. Okay, now I need to test. Did that work? So if I come back over to my website that's running here, and I refresh the page, it's still the same. Why? What's that? Yeah, I didn't commit it. So that's one thing for sure. I didn't commit the code there, but I can see that like there's a difference here. So I've saved the file. And the other thing I didn't tell you is that this website is just running on my local host. It's just running right here. But so if that's the case, why hasn't it changed? What's that? I haven't run Chef Client. So I haven't said, I've changed the policy in Chef, but I haven't told Chef to rerun, to apply this new policy. And so the way that I'm doing it is actually through a tool that we have within the Chef ecosystem called Test Kitchen. Have you heard of Test Kitchen? Has anyone not heard of Test Kitchen? Yeah, good, good, good. It gives me more to talk about if you say no, so thanks. So Test Kitchen, let's describe what Test Kitchen does. And the way that I'm going to describe to you what Test Kitchen does is by looking at this file here called a kitchen.yaml. So Test Kitchen, at the 10-second description of Test Kitchen is a test harness for you to set up test infrastructure nodes and apply policy to them and validate that it is what you expect it to be. That's at a high level, that's what it is. Now, Test Kitchen, I said it's in the Chef ecosystem. That's kind of a lie. Test Kitchen is an open source framework. So you can use it with Chef. You can use it with, I went in and hand crafted this server and then I ran Test Kitchen to build it or whatever. Ansible, Puppet, whatever you want. I don't care what you're using. I care deeply what you're using, to be clear. But you can use Test Kitchen with any of these things. So how does Test Kitchen work? It's a test harness. So what it's going to do is it's going to create virtual machines for you. And so one of the questions you might have is, where is it going to create those virtual machines? That's determined by the driver. So you can see here the driver that I've given or I'm using is called Vagrant. Have you heard of Vagrant before? Anyone not heard of Vagrant? Good. All right, so all of you that have heard of Vagrant, after I say these next words, you might want to come up and punch me, but it's enough for the people that have not heard of Vagrant before. Vagrant is essentially a nice Ruby wrapper around Oracle's VirtualBox. Now, that's all we need to say about Vagrant. There's much more to it, but that's all you need to know about Vagrant. So when I say this is going to create virtual machines for me, it's going to create a VirtualBox machine locally on my system, which might be a lie. It might be VMware that it's creating, but we'll just say VirtualBox on my system for now. We can give it a name if you want. We can set up some networking things. So here I'm just forwarding guest ports to my host, so I can go to like localhost on port 80. I'm also set up a private IP for it, what have you. So this creates virtual machines for me using this driver. Now, you can use the Vagrant driver. There are over 100 other drivers that you can use with Test Kitchen as well. So Vagrant is great because I can spin up virtual machines right here on this box. But if what I want to do is stand up a full distributed ecosystem or full distributed infrastructure, and I need like 20 different virtual machines, Vagrant will totally allow me to do it. The compute resources and memory resources on my machine, not so much with 20, right? But we could use EC2 as a driver or Azure or OpenStack, so you can do all of that stuff off board if you like. Now, once it's created this environment for you, the next thing it will do is it will go and configure that virtual machine for you. And the way it configures it will be based on the provisioner that you have. So you could write a simple bash script as your provisioner, or in our case, we're using the Chef client, Chef 0. Now I'm going to skip the verifier. We'll come back to that in a second. But it's going to create platforms for us. How many platforms is it going to create and what types of platforms? That's determined here. So here I'm creating one Ubuntu 16.04 instance. It's going to be provisioned with the Chef server, I'm sorry, with Chef 0. And the recipe that we're going to run to provision it is this simple web default, which, if you'll recall, was the one that included all of those other recipes. So previously, you know, it's a cooking show, so we had to cook some stuff in advance. I set up this kitchen so I can run this command, kitchen list. And kitchen list will tell me that I'm in the wrong directory. So it doesn't actually tell me that, but that's how I read those words. So I'm just going to cd into cookbooks, the simple web, and then I'm going to kitchen list. And what we see here when I kitchen list is that I have one instance, the default 1.2.16.04, it's provisioned with Vagrant, or driver was Vagrant, chef 0 is our provisioner. The transport is SSH, and its last action was converged. So kitchen has a series of steps that it will take in its life cycle. The first would be to create the virtual machines. The second step would be to converge them. So converging them is going to apply whatever provisioners you set up. So I've made a change. I want to verify that change. I'm going to test that change locally. So to test that change locally, I just need to run kitchen converge. And that's going to reapply the chef recipe that I set up. And we're going to see here that it's super unhappy with me because it's not able to log in. So what we're going to do instead is we're going to kitchen destroy. And yeah, so that's the other thing about live coding with me. When I type and talk, destroy. Sometimes it will have typos, and then you are left with two options when you see my typos. You can wait and then point and laugh. Thank you, Jessica. Or you can correct me in advance and be like, yo, don't hit that magic key. So now I'm going to run this kitchen. I said create was the first step and then converge. I'll just run them both in turn. So we're gonna run a kitchen create. And what this is going to do is go and launch a new virtual machine for me. It's going to pull down that Ubuntu 16.04 and start it up. And I'm going to go ahead and take a sip of my beer. And we're going to see how this goes. It's super not happy. There it goes. All right. Whew. All right, so that's good. And then the next step is we're going to kitchen converge. And just to show you that this is totally real, if I come back to this page and refresh where I had my super awesome website before, that thing is now gone because I destroyed that virtual machine. I've now created a new one, but I haven't provisioned my chef code there yet. So I'm going to kitchen converge. The challenge with this kitchen converge is it's actually going to take about 5 to 7 minutes as it goes through and does all of the things that are included in that recipe. But we can talk through some of the things that it's doing. So the first thing that it's going to do is it's going to log into that machine and make sure that the chef client has been installed so that it can provision it with chef 0. It sees that it hasn't, so it's going to go ahead and download and install that chef client. Then it's going to run through my run list. While that's happening, we're just going to create a new window over here. We're going to cd into that same directory.
Can you like, there you go.
Yeah, I'm totally going to make it bigger for you. And then I'm just going to, now I'm going to remove that directory that I just created because I didn't need it. Git diff, we can see there's just that one change. What I should do is I should actually wait for this converge to finish and validate that it's the correct blue. But, you know, you all saw me make that change. I've kind of done code review. I'm sure it's fine. I'm just going to commit that change. So I'm going to do a git commit -s-asv because that's just my flow. And I'm going to say updated. Oh. Oh, I did spell it wrong. Thanks. That's just a screw with the Englishman who did that. Yeah. Yeah. So let's do that, and then I'm just going to go ahead and push that up to Git because why not? So there. Now it's up on GitHub. This thing is going to keep running, but while it's running, why don't we look at some other issues that we had here? So proper blue is now closed. Let's see, what was the next issue that we had here? The next issue was the homepage should have the InSpec logo on it. So although we did see in our recipe over here on the website that we were writing out some images, the logo didn't appear. So there's a couple of things we're going to change here. The first thing we're going to do is use the right source URL or the source file. So this resource is using a cookbook file resource, which means that in this files directory over here in my cookbook, there's actually a chef logo.png that sits there, and there's an InSpec logo that looks like that. So we want to write that to the home page. So the first thing I need to do is make sure that I'm pointing at the right source file for that. And then if I go back to my attributes, we're going to see here that this actually determines how the logo appears based on the CSS. Currently, the default display is none, so we need to change that to inline. And we'll save that. Then we're just going to check back on that Kitchen Converge, see how that's going. It's still going, but now it's started to go through our run list. And you can see that it's doing the apt update. It's doing the Simple Web Apache. It applied the firewall rule, so port 80 is open. So it's just going to keep sort of churning through that. We're going to let that go. And I'll just come back over here, get status. And I have two changes here. So let's just make sure I understand what those changes were. I updated the display from none to inline, and I updated my logo source so that it's pointing at InSpec chef.png. So while that's going on, let me just commit that as well. So that fixes number 2. We'll get push that up. Because of course, as part of your good development workflow, you should be just fixing one thing at a time and doing separate commits for each one of those. So I'm going to practice good hygiene here, and that's what I've done. So that Converge is still running along. It's running that Simple Web hardening. That's the last step. So we're going to get there. We're going to get there pretty soon. While we wait for that, let's just get that one last issue knocked out. What was the third issue? Oh, we should use HTTPS, not HTTP, for the site. Seems reasonable. So what I'm going to do back over here, you can actually see that my Apache config, the open ports, is currently set to 80. I'm going to do the simplest thing I possibly can to make it SSL enabled, and I'm just going to switch the port to 443. There's some other stuff that's already happening in the background, but we're not going to dig into all of that because this is not the Apache LA meetup. So we're just going to switch over to SSL and call that one done. But I'm not going to commit that one just yet because I really want that thing to finish before I do. I maybe want to let that finish before I do. Yeah. So we're gonna let that keep running. We'll then come back and look at this. So, but from my perspective right now, I've fixed all the issues, right? I've closed out all the issues. I'm the developer on this app. I'm ready to push this app out to production. I have one small problem. The compliance team just walked into my office. Now I'm kind of stuck. Yeah. And they're like, dude, you can't push this to production yet. We have a bunch of controls that you need to follow. And if you're not following these controls, you can't put this application in production. I'm like, okay, great. Can you show me your controls? I'm like, yeah, we sure can. Here they are. I'm like, great. I can't do anything with this. Like, how do I take a notebook of controls and apply them to my server? And so now I get really concerned. And I don't know if you've experienced this before or not. Have you experienced this before? Yeah. Yeah. I used to, like, before I worked at Chef, before I got paid to get on airplanes and drink beer, like, I used to manage real infrastructure. And once every 6 months, someone with a notebook like this would come through the door. And our job was really easy. Keep them on the east side of the building, number one. Get them out of the building as soon as possible. Like, that was the job. And whatever we did, it was terrible, but we knew it would only last for the week or so that the compliance team was there doing an audit, and then we could get back to the real work. But that's really not, like, that's not how we should behave. It's pretty bad that we did that. So I'm going to do better this time. I promised myself I would do better this time. So I opened up this notebook and I was like, all right, well, what does this notebook look like? Like, what are some of the things that are in here? And one of the things that I found was that the compliance team in their controls, they're kind of decent humans. Look, they even said please. Like, that's very nice. If they can say please, I can probably conform and meet their controls. So they're asking us to run this thing, but how do I run this against my server? Like, this is just English. I don't know what I'm going to do with this. And the problem was that the executives at that organization were like, yeah, but if you don't do that, I go to jail. And so you're going to do that. And it's weird, but executives, they don't like going to jail usually, right? So what did we do? We changed our development process and we moved it from this. We said from now on, before we go to production, we must have a full security review of every change that we're pushing out. How many of you work in a place like this right now? I've ever worked in a place where, like, yeah, we've got to do security review before we go out. Did it ever feel like this? Like, this is what happened immediately after that, right? We started just blocking all of the releases. We were on this path. We were automating everything and getting to continuous delivery. And now you're throwing the security review in. It feels like a dam, and it's blocking up our progress. It's slowing us down. And the worst part about this dam actually wasn't necessarily the technical aspects. It was, look, we're pausing right now because we're in a security review. And then you have a product owner or a product manager come in and say, no, release date is Friday. This has to go out Friday. And we say, no, we're stuck in a security review right now. We have to finish the security review before we deploy. And then the product manager says, oh, no. Like, it's just one small feature. We can just poke one little hole in the dam and just push this one out, right? Everyone knows what happens when you start poking holes in dams, right? Like, they just fall apart. So we said there's got to be a better way. Let's get rid of that security review. And instead, what we'll do is we'll scan once we get into production, and we'll catch all of the errors there. But of course, this is horribly flawed as well. How many of you have an oil light on your dashboard? Yeah, when that thing goes on, it's kind of like this. It's too late. Like, stop what you're doing right now and put oil in your car. That's important. So we need a better way, and that's what InSpec provides for us. So InSpec is this open source framework that we have that allows you to manage your compliance as code. So I remember the days, well, I'll tell that story later. So InSpec is compliance as code. Let's pause before we dig into InSpec and just check in on how that thing is going over there. Woo, that's super terrible. It got much bigger for you, like almost too big. Let's see. Oh. I think I know how to solve my problem. No, don't go there. I'm ready for you. Better. And all right, great. It looks like our chef client finished. Let's check in on our chef client. If I refresh this page, all right, it's the right color blue now. That's awesome. Well, you don't know if it's the right color. Well, actually, you all know how to read hex colors, right? So you know that's the right color by looking at it based on what I copied and pasted over there. But the things that haven't happened is our logo hasn't shown up and we're not running on HTTPS yet. So what we're going to do to fix that is we're just going to run another kitchen converge. We should also make sure, I did save everything, I hope. Well, we'll find out in just a second. The good news is this kitchen converge won't take as long. And we should see the things that changed. Yeah, I saw the, yeah, I think that should be good. So now if I refresh this page, it's not going to work. Why not? I did. I changed the port. So what I want to do instead is go to HTTPS and go over here. And then this is probably fine. I'm sure you didn't even see that. It's totally exactly what our compliance officers want. At least it's running at HTTPS now. But we have our logo and we have the right color. So yeah, we've closed out all of those tickets. Let me go ahead and get diff. Yep, git commit. What did I do? Change to port 443, and this closes number 3. Now I can git push that up. And now let's talk a little bit more about InSpec. There's a Facebook notification for me. I hope y'all got to see that. Let's see. And it is not happy with me.
Oh,
Jeez. Go back to that. See, it's not actually the live coding that's hard.
PowerPoint.
It's the PowerPoint. All right, I'm feeling.
I seem to remember one of our executives saying that we should be using Google Slides. That's what I heard.
Executive. All right, InSpec, compliance as code. Beautiful. So we can take that document, that notebook that our auditors gave us, and we can take all of the words that they wrote and turn those into code. So here's one, and I'll write this live for you in a second. This is from the CIS profile. The CIS is the Center for Internet Security. They put out a bunch of profiles that say here are all the ways that you need to harden your operating systems, how you harden different applications, and so forth. So one of their sets of rules is around SSH and how you set up a secure SSH protocol. So this particular control is number 6.2.1, set SSH protocol to 2. And so I can take the title of this thing and actually create a control in code and give it a title. It has a description here. SSH supports 2 different protocols. Make sure that you're using protocol 2. It has a test. So it tells me that you should grep your SSHD config and figure out what its protocol is to make sure that that's right. I can write that same test here in a much more expressive language than grep. I mean, I know grep is awesome, but we can actually use InSpec to write that control. And then the other thing that we can do is we can set up an impact level. So how important is this? When you run and find a bunch of compliance things that are outside of policy, you want to fix the ones that are most important first. So we can describe all of that here within InSpec. Now, the thing that's really great about this is when that compliance officer, that compliance person, that auditor comes to you with that notebook, and they say you should use SSH protocol 2, my tendency is to act like a 4-year-old. Say, why? And they say, well, because it says in section 6.2.1 that you should use protocol 2. To which I say, why? Right? Like, and I just keep asking why. Like, why do we have to follow these particular rules? Well, the beautiful thing about InSpec and the ability for us to capture this metadata here is we can actually start answering those whys directly in the code. And that code can live in a version control system. So over time, as the rules change, we can actually look at our Git commits and figure out why did this rule change? Who changed this rule? Who approves that we change this rule? Or whatever the case may be. So let's go ahead. I'm going to go ahead and just write out this InSpec right here. And by write it out, what I mean is exactly that. I'm going to write it out. See what I did there? So here I am. I'm just going to write a test for SSH 621. was the name of that control. And there I just typed it live in front of your eyes. It's pretty good typing. Mostly with no typos. It looks like it's all pretty good. But we can see this a little bit better now. So couple of things here. So first, we create a control. So that's the thing, SSH 6.2.1. It starts at this do and it ends at this end. And then we have all this metadata that we can set up in here. So my impact, my title, my description. I should probably use the full description there, but I'm lazy, which is a bad thing, but I'm a developer, so, you know, lazy. And then we have the actual test itself. So we describe SSHD config. This is, like all of this is InSpec, but this describe block is the real magic of InSpec. So InSpec itself is built on top of RSpec. So if you've done any Ruby programming, you've probably encountered the RSpec language, and this will look very familiar to you. It's just an RSpec test. But there are some really nice things here that InSpec gives me when I write these tests. If you recall from the written out control, the CIS told us to grep a file to figure out what the protocol was for that file. And it told us the location of that file. Well, SSHD config is a resource within InSpec. So it understands where does that SSHD configuration file live on an operating system. Where is the default location for this? Whether we're on Ubuntu or CentOS or whatever, it knows the right place to find it, and that can be operating system specific. Yes?
So if I'm running Solaris 9 and I've installed OpenSSH and I'm running OpenSSH instead of SSH, will it go find the OpenSSH config? Or
no,
will
but you
it
can.
Go find the SunSSH?
It will find. So, like the real answer is I don't know, but it'll find one of them. Okay. Which isn't like an acceptable answer. I understand. But what you can do with these resources, if you've written it to a non-default location, you can specify that path here also, just like you would like the name of a resource. So you could do describe SSHD config. It's at /ops/openSSL SSHD config. Now, why would you want to do that instead of just looking at a file? The reason why is InSpec also knows what is the format of an SSHD config file. And it uses keys and values that are just separated by white space. So I can say it's, and then point at a key, and it will scan that file looking for this key. And then it knows that the way an SSH config file works, there aren't equal signs between them, there aren't commas between them, you know, it's just space, white space between. Then it will pull that value. It also knows that protocol shouldn't be commented out, right? Think about writing a grep to figure out what protocol is specified here. What are some of the things that you might mess up? Like you might forget that, oh, maybe they commented out the protocol and I forgot to make sure that the line starts with protocol, not with a hash mark. It might have 2 comma 1, so maybe it supports both protocols. I need to make sure it only has number 2. So here we're saying the SSHD config, its protocol should CMP or compare to 2. And this CMP really just treats integers and strings as identical things. We don't really want to get into like, let's read the value and then turn it into an int and then compare it to the number 2. Like that feels like a whole lot of work. So we just use this little comparison operator method here. Let's see. So it knows how to read SSHD config files. It also knows like some files are written as key equals value, and it knows how to read those, right? And maybe your configuration is written in YAML. It knows how to read YAML files, and it knows the appropriate file type for each one of those. Now, what other questions can I answer for you about this? Yeah, Chris.
So if it's an impact of 1, does that mean it's like not important, or does that mean it's like really important?
That's critical. So the values, the impact level is basically 0 to 1. And there's actually an agreed upon standard like within the security realm of like from 1.0 to I don't know what it is off the top of my head, like 0.8 is critical. And then like from 0.7 to 0.5 is, I don't know, whatever the less than critical is. Like not quite urgent. Probably high, yeah. High would make sense, right? And like the 0 to 0.2 is probably low, something like that. But there's an agreed upon ranges for what those words mean, and InSpec kind of follows that as well. All right, so I've written this control here. I haven't really written it, as you can see. Now I've written this control here. I need to execute this. So InSpec, as a tool, allows me to execute these controls a number of different ways. InSpec itself, in addition to being a framework, also is a command line tool. So I can InSpec exec SSH, and I'm just going to do sudo just because I'm going to go and read an SSHD config file. And this is going to exec that InSpec test locally. So this is going to read my Mac to see if I'm compliant with that. And I'm going to do my best to not say my password out loud as I type it, which also means I'm likely to screw it up. There we go. All right. So it failed. It expected it to be 2. It got nothing. So what's going on there? Let's just take a look at my file. And actually, it's right there at the bottom of the screen. Do you see what's happened? It totally says protocol 2, but again, it's commented out. So if I were to go ahead and just fix that locally, you should never just fix a config file like that. But, you know, it's probably fine. And now I rerun that test. Sure enough, that's working fine for me. So this is really cool. So InSpec allows you to write those controls. You can execute them locally. But executing them locally, while cool, like I'm not being asked to validate that my laptop follows those controls. I want to validate that this server that I'm working on validates those controls. With the InSpec command line tool, you can also execute these controls across SSH. And to do so, you needn't have anything installed on that remote machine. So when we did the Kitchen Converge, it installed Chef Client. We don't need Chef Client to do an InSpec validation across a remote machine. So you can do it via SSH, and here you just set, so here this command, I've set my identity, my SSH key. My target is an SSH at some host, whatever the IP address or the name of that host is, and it will SSH into that machine, execute the InSpec controls locally, and then print back that result. Now, maybe you don't run SSH because you're in a Windows environment or you have a mixed environment. It will do the same over WinRM. So I can set my target to WinRM. And then if you're using containers, specifically if you're using Docker, you can actually go against the Docker wire protocol and just point at a Docker image ID or a, not an image, container ID, point at that and just execute those tests there. So that's really cool. We can write these controls in a very descriptive language that gives us a lot of power. And the tests themselves are pretty powerful. But then we have all that metadata that surrounds the test as well, like the title, the description, the impact. We can capture all of that. I can run it locally. I could run this against my test kitchen instance. I could run it over SSH. I could run it over Docker, over WinRM. Now, InSpec itself does all of these things, which are hard to read from the back of the room, so I'm just going to tell you a little bit about them. So there's mechanisms for policy definitions, which include things like inheritance. So we've set up one single control, but I could create a bunch of controls and put those into a policy document. And then I could actually use that policy document as a building block. Much the same way in our recipes, in our default recipe, we included other recipes. I could include other compliance profiles. And we'll see an example of that. We also have native packages for Windows, for Mac, for Red Hat and Ubuntu. So you can run InSpec natively in all of those. There's some patch management. We do Windows support, remote execution, and then of course it's baked right into the Chef ecosystem as well. So if you've ever installed the Chef development kit, you installed InSpec as part of that. That comes with the Chef development kit. And then there's also support for Test Kitchen. And we're going to see an example of that in just a minute. And then there's also this thing called the audit cookbook. And Chris is going to remind me at the end, if I don't talk more about the audit cookbook, to talk about the audit cookbook and how that works. But for now, what I'd like to do is hopefully navigate my computer better than I did last time. And I just want to check on my issues. It looks like HTTPS is all done. So it's good. I'm ready to go, except somebody came along and opened another ticket on me. damn it. I thought I was ready to push to production. So it says here that our application must follow all of our standard controls. So Jessica gets to play the role of my compliance auditor tonight. She came in and said, no, you can't go to production. No. Yeah. Yeah. You should totally borrow the tie. This application must comply to all of the controls in Nathan Harvey Acme InSpec profile before deploying to production. So let's just go take a look at what that profile looks like. So this is just another repository up on GitHub that has our company's InSpec controls within it. And as you can see, as I promised earlier, I write none of my own code. I only steal from other people. So this is completely just a forked repository from someone else. But the way that these controls work, or the way that we describe these controls, is through this InSpec YAML. So this gives me, this is what an InSpec profile looks like. I have the name of it, title, maintainer, sort of just high-level metadata about it. But then you can see here, it's dependent upon some other compliance profiles. So when I talk about writing a compliance profile and then cobbling them together so that you have a full compliance profile, this is what this looks like. So this particular profile depends on my Linux patch benchmark, the Windows patch benchmark, the OS hardening, SSH hardening, and an SSL benchmark. And we can point off to Git repositories that will pull each one of these in for us. And so one of the things that I can do then, by having these controls, it's great that I can pull them together. So I have these 4 different controls. I've pulled them all together into one InSpec profile. But then what about if, and maybe you've seen this before, your company or your auditors lay down a thing and they say, you must follow the CIS standards for Red Hat. And then you go and say, okay, but if we follow all of these standards, our applications won't work. Our machines are basically inoperable. So I need exceptions. And then you negotiate with your auditor about which exceptions you need. They grant those exceptions after some many hours of negotiation, I'm sure, in a full paper trail because auditors. But what you can do is you can actually just include that right within the code. So here in this InSpec profile, I'm including all of the controls from OS hardening, but I'm going to skip number 6 because I got a special dispensation about number 6. I don't have to follow OS 06. And then OS number 2, usually that's a critical, but we're going to knock it down to a high. Or maybe usually it's a low and we're going to knock it up to a high. So we can actually override what is the impact of that control. And then of course we could override additional attributes here so I could know, like, why did we change this to a 0.7 when it's usually a 0.2? Why do we care more about this one on this particular set of profiles? So this is how you combine all of those profiles. So now I want to show you a couple of things. I want to show you how do I take the compliance profile that Jessica just told me I have to follow for my application. How do I build that into my development workflow? And then if it throws any errors, how am I going to remediate those errors? So the way that I'm going to do that is over in my test kitchen. One of the things that I had here in my test kitchen was a verifier. And we said the verifier is InSpec. So let me just show you how that works right now. So I can run kitchen verify, and it's going to run some InSpec controls that I have already in that cookbook. And this is really great. It tells me that Apache should be installed, it should be enabled and running, it should exist, these files should exist, and so forth. This is really just integration testing that we're doing. And if I look at the cookbook, you'll see that there's a test directory, integration, and then within that, a default file. So here, it's just saying that, hey, this package should be installed. These are other types of InSpec resources. This package should be installed. The service should be enabled and running. I could add another thing here. For example, describe port 443. It should be listening. Because if you'll recall, that was one of the changes that we had to make. So let me go ahead and run that as a new InSpec test there, and hopefully all will go well. So sure enough, port 443 should be listening. So I've now validated that as well. Yes?
Putting quotes around 443 makes my eyes bleed. Is it possible to pass it just as an extra?
Sure.
Thank you.
Maybe. Let's see. Yeah.
RoboCop would yell at you.
Yeah. It's cool. I don't RoboCop. Yeah, we could put it in or not quotes. We could have it in a parenthesis like we've done everywhere else. Like I should follow like what everyone else has done in this thing. That's actually more idiomatic to the rest of the file. But what else? We'll do it the way you like, Chris. How's that?
Makes me feel special.
Okay. Eyes less bleedy?
Yes.
Okay, good. Good, good. Okay, so kitchen verify, if I go back to my kitchen.yaml, which is here, you can see that my verifier is InSpec, and the verifier is going to run a bunch of InSpec tests. It's going to look at test integration. I can also, watch, this is pretty easy to do. I can also just point at, it's super easy when you have a notes page in another tab that's open, but I can just point right at that URL that Jessica asked me to follow those compliance profiles for. And now when I run Kitchen Verifier, it's not only going to run my integration tests that I have locally, it's actually going to go out to GitHub, download that profile, plus all of its dependent profiles, and run all of those controls against my test kitchen. So let's see how that goes. And spoiler alert, it's not going to go well. I mean, it's going to work, but there's going to be a couple of failures here. So here we go. It's going off and grabbing that from my target. So I pointed at that InSpec profile. It downloads it. I can see my integration tests are still doing well. There are 40 successful and 76 failures in my profile summary and 88 test failures in my test summary. So this is a problem. I can't go live with this. I can't go to production. And the problem is that my OS isn't hardened properly and my SSH isn't hardened properly. So now I need to start digging into what are each one of these problems. So as an example, SSH configuration Debian banner should equal no, and it's not set at all. So what I could do is start going through each one of these one by one and fixing these up. But as it turns out, there's another thing that you've probably heard of within the chef community called the supermarket. The supermarket is a place where, as a community, we can write cookbooks and then share them with the rest of the community. So if I go out here and I search for OS hardening, we find, what do you know, there's a cookbook called OS hardening. There's also one for SSH. I think it's SSH hardening. Sure enough, there's an SSH hardening cookbook. And if we look at what this cookbook does, well, we won't look at what this cookbook does. It hardens up those things. So what if I just, like, I don't know, this is definitely how you should totally work. What if we just said, this cookbook depends on those two also. Let's say it depends on OS hardening. And let's say it depends on SSH hardening. Now I'm just going to, what do I need to run here? Kitchen what? Converge, right. I need a kitchen converge. And this is exactly what you shouldn't do. I just went to the web, ran a search, found something that was named similarly to what I was looking for. Now I'm just going to download it and run it and see what happens. Probably not the right development process to follow, but for a meetup and something that I've prepared, totally fine, I'm sure. So it's finished. It updated a bunch of different resources. Did I save that file? I did, okay.
Yeah, but
go ahead.
Well,
Nope.
You can go for it.
No, you can
You're
save
totally
me.
missing like an include recipe line.
Oh yeah, I should probably, like, now that those things have been depended upon, maybe what I should do is also include them. Yeah, that's a good call. Why don't I come over here and do a couple more include recipes? Thought that was quite a few things to, yeah.
Is there a reason why you're not putting it in the how is it called? In the simple web hardening recipe, and you're putting it in your
Laziness?
Okay.
No, no real reason. Now I'm going to kitchen converge. This should take a little longer and change maybe more than 12 resources. Well, we changed 30 resources, so that's more than 12 if my math is right. Let's run a kitchen verify. What could possibly go wrong? Now I have 0 failures. I'm skipping 5 things, but they're not important. That's why I'm skipping them. So here we go. We have all of these things have now been fixed. Let's do a get status just to close out the whole thing. Let's see. We're not going to add that SSH 621 because that's not really part of our cookbook. Everything else looks like it's really part of our cookbook, so we should just go ahead and include that. So I'm going to git commit. Ooh. I hope it. Sometimes I lie. I'll just push that up, and then I'll get status. The only thing should be that one little. Yes, that's exactly what I meant. Why didn't you fix it for me? All right. So I now have. Oh, you know the last thing we should do? We should make sure our site still works now that we've hardened it up. Sure enough, it's still just as awesome. Right, so there we applied our compliance profile. We remediated those issues with something from the supermarket. So InSpec, honestly, I don't know about you, but I remember the days when every server that I managed in my infrastructure was beautiful because I built it by hand from scratch, every single one. And then one day I found and started using Puppet, and then I found and started using Chef. And that was amazing. And I felt like I became a professional that day. Like I remember the day in the shower, I'm like, oh, the next change to my production infrastructure is going to start with git commit versus me just logging in, banging on the keyboard to see what happens. And that, like, then I was a real professional, I felt. And the power that or infrastructure as code gave me, like to this day, is still near and dear to my heart. Like that was transformative in my career and the way that I worked. With InSpec, I really feel like we're bringing that same level of control, that same level of power, and frankly, that same level of joy to this idea of compliance. Compliance as code becomes so powerful. I'm really, really excited about it. The other thing, if it wasn't clear, InSpec it's an open source framework. We tonight configured the servers that I was working with, or the test kitchen I was working with Chef. InSpec doesn't care how your server is configured. You can use InSpec on the machines that you built by hand to run those controls. So we truly are taking our compliance, turning it into code, and moving it into the development phase of our workflow. So as a developer, I can run those InSpec controls locally on my machine before I even put this into my pipeline to get it out to production. And that is really, really powerful. These are all of the available resources that InSpec gives you. So we saw like the SSH deconfig. There's other things here like audit, deconf, apt, there's gem, there's mounts, MySQL sessions, or MySQL conf, MySQL session. There's stuff with Postgres and Postgres conf. So there's lots of custom resources that are built into the language. And in fact, if what you find is you have things that you need to test that aren't built into the language, you have simple things like exec, like you can exec a grep or run some PS command or something like that. But you also have the ability with InSpec to write your own resources, which you could then use within your controls. You can submit back to the project because it is open source, and maybe others can use those as well. We also, on the supermarket, in addition to being able to share cookbooks, we actually have a way for you to publish and share InSpec profiles. So under the tools and plugins section, you'll see there's a link here at the bottom for compliance profiles. There aren't a whole lot there, but the Apache DISA-STIG is here. Is that a wave or and a question, just a wave? Okay, all right, great. I don't want to, I mean, you did give me a lot of work to do tonight, but I don't want to ignore you. So you can write and share compliance profiles here. You can also find a bunch of, and by a bunch, I mean there's maybe 8 or 10 here right now, but it's a burgeoning part of the community that I'm, like the reason I'm here is to encourage you to write more of these and share them with the rest of the world. So create custom resources, create custom profiles, share those. There's a whole website dedicated to InSpec, inspec.io, which includes a bunch of tutorials. You can do demos right in the browser, like, so you don't have to install anything. I'm not sure why you would want to do that after tonight. Like, I hope I've convinced you that you can at least download the thing and try it. There are also tutorials on Learn Chef about InSpec. And then just kind of where InSpec fits within sort of the full Chef ecosystem. So Chef Software, the company that pays me, we are responsible and core maintainers of 3 open source projects. Chef for infrastructure automation, Habitat for application automation, which you can come to Burbank and we can hack on that tomorrow, and InSpec for compliance automation. On top of that, we have a commercial offering that we call Chef Automate. And Chef Automate gives you the workflow, visibility, and compliance that's necessary for you to create a transformative, high velocity, software-driven organization. That's what Chef Automate is all about. Free and open source, commercial. We would love it if we had a commercial relationship with the company that you work for, but I'm happy, just as happy, if you're using and sharing any of this open source stuff. Now, when you do purchase Chef Automate, the things that you get that are InSpec related, or you get some compliance profiles as part of that. So you get the CIS benchmarks. They come as part of your Automate subscription. You for a bunch of different things, like for CentOS, for IBM AIX, for Ubuntu, for Windows, and so forth. All right, I have 2 more slides to share with you. The first is I have to encourage you to come and submit a talk for ChefConf. As we mentioned earlier, ChefConf is happening May 22nd through 24th in Austin. You have a story to share. You should share that story at ChefConf. So please go to chefconf.com and submit that. And then I have one more slide, but I also have a thing to tell you because Chris reminded me. He didn't even have to use his words. How does InSpec work within this Automate thing? So first, there's the compliance component of Automate. What compliance will do, it's actually, you know, at the beginning when I said scanning in production, like that's kind of a failure. Compliance will scan in production for you. It's not really a failure. Like you should still scan in production and see like what's happening across your infrastructure. But the compliance component of Chef Automate is a place for you to store all of your compliance profiles that you've built. And then actually the way that you would integrate your Chef client and your InSpec profiles is through a thing that I mentioned earlier called the audit cookbook. And the way that the audit cookbook works is like this. Within your Chef client run, so it's the policy for your Chef client, you specify the audit cookbook as one of the items in your run list. You have a number of data attributes that you can manage for each of the nodes that says, these are the compliance profiles that should be executed on this node. And then what happens when the Chef client runs on your node, it will hit the audit cookbook. The audit cookbook sees these are the compliance profiles that I need to have executed on me. The Chef client will talk to the Chef Automate server and say, hey, execute these compliance profiles on me. So now the compliance system will reach into that server, execute all of those profiles, and then report back the results in the visibility component of Chef Automate. And by doing this, what you've actually done is you've implemented what we call continuous compliance. Because if you think about the way your chef client runs, you typically have your chef client running every 30 minutes on the nodes that you're managing. So think about the ability to run your compliance scans, not ad hoc, not when the auditor shows up every 6 months, but every 30 minutes. And then when you have something that falls outside of compliance, you can actually alert on that, you can actually put people to work to fix that, put code to work to fix that. So that's kind of how the audit flow works. And the nice thing about that then also is that you can separate who writes those profiles, who controls which profiles get applied to which machine, from the people that are writing, this is the configuration of this machine, this is what the policy should be followed is. Chris, you have a question.
Hi. So if I currently have a Chef Automate subscription,
Mm-hmm.
Who would I reach out to get access to compliance and the CIS benchmarks?
Your sales rep.
Fantastic.
Yeah. Who will probably talk to you. Like, I don't know. And if you aren't sure who your sales rep is, you can reach out to me. You can reach out to Jessica. You can reach out to Chris.
Yeah,
We'll all help you. We'll all help you. Like if what you do is come to one of us and say, my company wants to pay you money, we are generally okay at helping solve that problem. Yeah.
I try.
All right. Thanks, Chris, for that question. So I just wanted to close with another picture of me because in case you forget what I look like, there I am. And to say thank you, and then also ask if you have additional questions that I can answer for you about InSpec or compliance. Yes?
Is there a file output for InSpec? So say you output your XML file to an XML file or something?
Right. So with the compliance bit of Chef Automate, we will generate a PDF report that shows you all of the stuff. We also, we'll show you the compliance status based on the profiles that you've executed against. But then we also take that data and we send it off to the visibility component within Chef Automate. And from there, with the visibility component of Chef Automate, you can stream that data out in a number of different formats to wherever you want. So
but not natively in the open source.
Not natively in the open source bit, right? Yeah.
So you can't just use native
it's
RSpec outputs?
I'm not going to answer that with a really confident answer. If you can't tell.
Conceptually, just knowing a little bit about how it's built, I would guess, and this is totally a guess, you might be able to actually output using one of the RSpec.
Yeah. Yeah. It makes sense that you should be able to do that. I'm also a little hesitant to fully agree to that answer. Yes.
If your compliance officer comes to you and says, can you prove to me that the correct compliance profile has been executed against all machines?
Yes.
And the critical word in that sentence is correct.
Yes.
Meaning someone has configured the right one.
Sure.
How do you answer that question?
Sure. So I think the other critical question is all machines. The correct profile is one concern that you might have, and all machines is another, because it's going to depend. It will execute on all machines that you tell it to, which is likely a subset of all machines, right? So we have to solve for that. And for that, Chef is going to run against all the machines that you tell it about, right? Or InSpec will run against all of the machines that you tell it about.
Could I generate a report of all the machines that had it run against?
You can absolutely generate a report of these are all of the machines and these are all of the compliance profiles that have been executed against these machines. You could give a report. Now, sort of auditing that report, that these are all of the machines and these are
machines.
okay.
Because I can compare, describe it easy to describe instances.
Sure.
And make sure that I've got
everyone there.
So
yeah.
my concern is more around, should I run the Postgres compliance on this particular machine?
Right. Oh, so there's another thing that's kind of nice. If you run a bunch of Postgres controls, one of the things that InSpec will do is see Postgres is not installed on this machine. Therefore, it makes an assumption, I don't need to run the Postgres controls on this machine because there is no Postgres here. Otherwise, they would all fail, which would be bad. So you could include those Postgres profiles on all of your machines, and then Postgres controls would be executed only on the machines in which Postgres is actually installed.
So if you've got Postgres running on a random machine, you'll know about it because it'll blow
Yeah,
up because it's probably
it
not
would find it.
But
Yeah.
there's something really cool here. Now, instead of the auditor handing me a binder of paper, I can hand them a binder of paper and say, here, it's all in here. You tell me.
Just like my compliance team, I'll go and run like pre-configured reports in my logging server.
Exactly.
Anthony, if you're still there, thanks for joining us. I'm going to sign off and say good night.
Oh, man, you have live stream.
There he goes.